Amazing. Well, I'm super excited to have everyone here. There's a lot of people. Like usually we have like 10, but I guess it's a super hot topic. So welcome to another like YAIG. I think that's how we decided how to pronounce it. Roundtable. We have 3 great guests today, which I'll introduce in a second. And then also my co-host Alex. So generally speaking, like rules of the road on this is usually there's a couple like top level questions like Alex and I are going to ask. I think our general desire today is like really explore the intersection of, streaming technology and how that will impact the way we build our applications. So less on the data side, but more on the application stack. But we'll start with some broad-based questions around streaming in general to bring everyone up to speed. I'm a newbie, but Alex is not. So there's kind of like good cop, bad cop going on in the dynamics. So expect like low ball.
There is no bad cop, Ian.
and Alex has actually built some systems here, so he has some more ideas. Generally speaking, rules of the road though is like our general thesis or philosophy is just like have a discussion. We kind of just want to get to ground truth and figure out like where's the tension, right? Like, and what's the potential future, and then what are the things that might be stumbling blocks on that road to this like potential future. And that's generally the idea. So without ado, I'm going to introduce Alana, who is the CEO of Readyset. Alana, I would love for you to like give us your like one-line intro. This is your moment to
Yeah, for sure. Hi, I mean, you did a good job with the one-line intro part. I'm Alana, I'm the CEO and founder of Readyset. We're building a SQL caching layer that you can slot in front of an existing database, speed up reads. You don't have to do any cache maintenance or anything like that. And as you might have guessed, we use streaming data flow under the hood. So dig into that later, I guess.
Super excited to learn more. Awesome. Thank you. Hojjat, would you please introduce us to you and your company? I think you're the CEO of Deltastream. Yeah. And you're muted, my man. Yeah. Oh, I think you're muted.
Thank you. Yeah, my name is Hojjat, and CEO and founder at Deltastream. What we build is we call it streaming serverless SQL database for managing, processing, and securing your streams. So imagine you have Kafka or Kinesis or any of these streaming storage layers. So we have a relational layer on top of that you can do all of the management, processing, and securing, similar to the way that you would do in normal databases.
Amazing. Now, last but not least, in our eyes, Jamie Turner, who is the CEO of Convex. Give us a little intro, my man.
Yeah, hey everybody. I'm Jamie, CEO and co-founder of Convex. Convex is a transactional backend as a service that supports kind of universal streaming and subscription. So definitely have a lot of similar interests to the other two CEOs that are talking here.
Awesome. And then Alex, you should introduce yourself before we get the show on the road.
Yeah, so I'm Alex. I'm one of the moderators of the YAIG Discord. So in a previous life, a long time ago, I did work on a relational algebra that managed, among other things, a relational algebra over streams that managed, among other things, all like Windows 10 notifications at launch. So not the largest stream processing, like real-time, like stream processing system ever, but also not the smallest. So yeah, excited to chat. I've always liked the space. I just think it's really interesting.
Awesome. And then finally, I'm Ian, also a moderator and here to be your guest star, so to speak, in terms of helping us navigate this conversation with Alex. Background, founded a bunch of companies, but super interested in streaming, previously built Firebase alternatives at Heroku and a bunch of other places. So have done a lot of the reactive real-time stuff in the early 2010s. It was really hard. And now there's all these amazing technologies out there that actually make this easier. So I'm super excited for this conversation. So I think what we really wanted to get understanding of and to kind of dive deep is like, first of all, to like understand like what does streaming actually mean? Like what does this word mean? And like what are the different use cases for it? So I want to start with Hojjat with you, because I think, you're more focused, like there's all these different places. You seem like at the lowest level layer in the stack. So I'd love for you to like for your perspective, what does streaming mean to you? And what are a couple of your most favorite use cases of streaming, or you see it as being most impactful?
Sure. As you said, yeah, I have been in this space for a while. Interestingly, in late 2000s. I was doing my PhD in publish, subscribe, and stream processing. That was a totally different world compared to now, after big data, Hadoop, and Spark, and all of these things came. And a little bit background on myself. Before founding Deltastream, I was at Confluent. And as you know, it's one of the pioneering companies in the stream processing and streaming world. So I would say the use cases part, we have seen a lot of evolution. I remember early days in Confluent, for instance, just introducing Kafka as something that people can use and get value from. That was a challenge. And thanks to companies like Confluent, now you don't even have to talk about like, hey, you need Kafka, you need the streaming, you need real time, and those kind of conversations that you may have. So the evolution that I have seen is very similar to the batch world. If you look at that, for instance, in the batch world, the first thing that, assuming the big data word that we are talking about, big data in the sense that Hadoops and that type of systems, the first thing came out was the storage. HDFS was the first thing that people started using it, starting getting value from it. And the next step was, okay, we have this data stored in this database, or in the storage service. What can we do with it? And after that came a lot of different processing systems, like starting with MapReduce and Hive, going to Presto, Spark, and other services. So I kind of see similar parallel here in the streaming world. First comes the storage layer. So I call systems like Kafka, Kinesis, PubSub, Pulsar. These are more like a streaming storage layer for us, the way that we see. And you don't do any processing. They're just pipes. Data comes and data goes. The next kind of like thing that people can do with these systems, once you have the storage layer available, is the processing, and you can get a lot of value from that streaming data that comes and process it in real time. So I kind of like see us similar place that, for instance, batch world was in, maybe after the introduction of storage layer, and then comes the compute. So we are trying to make that compute layer simpler. So it has been there for a while. You have systems like Kafka Streams, Flink, and Spark Streaming, and similar services, but it has been very difficult to use. So we are kind of like the next generation of these type of services that tries to simplify processing on top of these type of streaming data and open the door for much more use cases that you can see. On the use cases side, we just see more and more use cases every day. The minute that you have the simplicity of processing available, users and prospects, they come with the interesting use cases because they have the context on what application they are having and what type of businesses that they are running. And now that you have this tool available, they come up with a lot of interesting use cases that it starts with very simple ones like streaming ETL and pipelines, and goes to more complex things like anomaly detection and kind of like alerting, monitoring, and those kind of use cases. We can discuss this more in details after. I want to stop here and give chance to other people to talk about it.
Amazing. Thank you. Thank you. Alana, I want to ask you sort of a similar question. We're trying to get like an understanding of the space. I think you're operating at a streaming infrastructure, but operating like very specific with what your company's doing. So like same question, like what does streaming mean to you? And also like what most interests you in this space with these pieces of technology?
Yeah, so I think we're coming at it from a somewhat different perspective for sure, in the sense that to us, streaming is an implementation detail more so than something that we're necessarily building on top of this other infrastructure that companies like Confluent have created previously. I think drawing a parallel to batch processing is a good way of describing it, where you have the batch world where you have some computation that you want to run. You run the whole thing over the entire data set. Whereas with streaming, you don't have the expectation that you have all of the data at that exact moment in time. Instead, it's maybe like filtering in over many days, weeks, months, years, etc. And the idea is that you're essentially taking this new information and then reconciling it with the old results that you had previously over these longer time horizons, and you're hopefully doing it in a very efficient way. And that's kind of what we see ourselves as doing in the land of Readyset. Like what we're trying to replace ultimately these custom caching layers that you typically build on top of like a Redis or a Memcache, and to make that a little bit more concrete in this world of custom caching layers. Typically what you do is you're like, oh, okay, great. Like I run this query many times. Let me try caching it so that I get better read performance. I'll run it once against my primary database and then store it, in memory key value store. But then the second any data, changes in the database such that this result is no longer valid, you have to go back and like either evict it and recompute or do something else. Whereas with Readyset, we're taking this idea of streaming and using that to like keep the state up to date over time, such that you don't have to rerun it from scratch. So it's more incremental, and that leads to a better user experience. And so I'm really excited about this topic. I think all the other companies in this roundtable are also really cool. It's like different angles to different problems that all have the streaming flavor to them.
Amazing. Yeah, I think that's actually one of the reasons we chose our guests, was like, this is a big topic and there's so many people, the space is huge. There's so many people approaching it from different angles. And I'm super excited, Jamie, that you're like, if we were to think about like Deltastream below, and then we have Readyset, which is very focused app sort of development use case around caching. And then there's Convex, which is this sort of like much higher level abstraction. Jamie, I'd love to learn like how you think about streaming in the context of the work you do and what excites you the most about it.
Cool. Yeah. My background, my recent background at least, was running all of Dropbox's kind of storage and database systems for a number of years, the teams and all that. And then before that, kind of leading some engineering efforts on retooling how sync worked to Dropbox and stuff like that. So I had this very pragmatic, pain-oriented experience, right, about sort of wrestling to the ground, things like timeliness and invalidation, and just how you keep a system correct with things flowing around. But that was in a context that was out of necessity, very pragmatic. This is a business operating on this, like there's this inertia behind a set of technologies, and we still want to achieve a lot of these things, which we might call streaming or something like that. But Convex is very interesting because it's like we're reset, and the exercise now is this very idealistic exercise at Convex, right? Which is like, this is like, hey, if we rethink what is it we want here and try to use like a higher level language around it, like how radically could we change the way we talk about computing on the back end to make things simpler, or sort of like a pit of success where everything just kind of updates. There are no caches because everything is automatically a cache. So I think that that's the particular place where Convex starts to intercept the idea of streaming, is like, to me, then I can get abstracted again because I have the freedom to just talk in the in the abstract yet, because we're for these new projects that want to try something really different. So streaming is really that there's a set of entities that are interested in data, or probably a particular lens on data, right? Data with a certain predicate, data with a certain, like on a certain table, whatever, with a certain, filter on it, or whatever, a certain queue, whatever the abstraction is we would call it. And those entities could be like a person that's like currently viewing a UI that should update when there's new data. Those entities could be like another function that's going to advance the state to the next step, which is something like a workflow. And so streaming is really, to me, like an interest in knowing when data changes, right, in the abstract. And so Convex tries to approach it very much from that way. Like, why isn't everything kind of streaming? And like, not having the latest information or a fantastic handle to get it should be opt out instead of opt in, kind of a thing. And so, but we're doing that for brand new projects, right? So as opposed to, let's say, something like Deltastream, where they're coming in, you have some infrastructure and you want to get these kind of characteristics out of it. Convex is more, if you haven't written anything yet and you want to try something very different in a very different manner that has these kind of universal subscription, like guaranteed invalidation kind of things, guaranteed timeliness, convergence toward now, you can grab these abstractions and build in this really different way. And streaming, as we're calling it here, is a very big part of that, just due to the inherent nature of Convex.
That's a great, this is a great introduction. Really like painted a beautiful picture. And, one of the things that I'm like, we're most interested in is like diving into sort of these app use cases. And I think we painted, like, as I said, we painted this great picture. I think we started to answer this question, and I'm going to actually throw this one to you, Alana, because I think with the caching, it's almost the most grounded use case. How does streaming like change the way we build applications, right? Like, how does this actually change the, maybe the type of applications? How do we, what new things can we build? What moves the workloads? Like, it's a big question, but I think like fundamentally, like the thing that we're most interested in, like, how is this going to change the way we build our apps? Love for you to start.
Yeah, that's a great question. It changes a lot of things. I think to ground this discussion, it'd be helpful for me to walk through what I see as like the maybe canonical like application lifecycle that users tend to go through today, and then compare it to the world that we see when you're using Readyset. So I'll talk about web apps because we deal a lot in web apps and Readyset lands. Let's say that you have this like cool new idea for a social network. Why not, right? Typically in the first few weeks or months, you're just working on like writing the actual, the front end code, the features, making it great. You're probably going to choose like a database such as Postgres if you're being pragmatic about it, because it's a standard choice, can't really go wrong. That being said, like once you start to get any traction whatsoever, it's very likely that your single node Postgres database will start to fall over. And then from there, you have a lot of different options for what you might choose to do, depending on specifically like what you believe the problem to be. One example of this could be manually optimizing your queries. So you can like take a look, see like what queries are my ORMs generating that are being run against the database, and why are they slow? Maybe you could add a few indices, maybe you can like change the way that they're structured or something like that, but it's like a very like hands-on type problem that requires some amount of database knowledge to be able to get to the bottom of. So that's like option one. Option two is you might choose to build a custom caching layer, like I mentioned previously, where, same idea, you're gonna see that you're running maybe like a handful of queries 90% of the time. And if you can just get those queries to be a lot faster, suddenly your whole app will run a lot faster. That being said, as nice and simple of an idea as that is, that has like really profound implications for how you actually like write the code, like your code, in the sense that previously you had whatever ORM, or maybe you're just talking to the database directly, but probably you're using an ORM. And that is no longer valid, because if you're building your own custom caching layer, like it doesn't know what SQL is, it just knows that you're storing things in it. And so suddenly every time you had an interaction point between like to your database in your application, you have to like go back and kind of add in this logic to both like talk to the cache and then also maintain the cache's state over time, and figure out, am I going to evict at certain like touch points, or like what am I going to do to kind of keep the whole system together. And this is such like a huge source of bugs, there's so many like retrospectives from fairly large companies saying like, hey, like caching misconfiguration or something like that led to horrible failure and outage. And so like in addition to like rewriting huge parts of your application, having to maintain that over time, you're also like adding a lot of like operational complexity. And then the last is like maybe like read replicas, and typically you see those like in tandem with the caching system. If you're trying to get like data closer to like users, or if you're just trying to offload things from your primary database, you might throw a read replica in the mix. But of course, like with read replicas, you're still rerunning certain queries from scratch. And so if they were like previously very expensive just because of how complicated they were, or like the size of the data sets, like it's unlikely that that's going to be like a standalone solution that will fully solve your problem. And so these are your options right now, and they're all pretty complicated. Like they require a lot of engineering effort, and you kind of have to figure this problem out. And typically like a solution that you invest in will only scale so far, and so you're continuously reevaluating the problem. And so this was what inspired us to build Readyset. With Readyset, the idea is that we're going to provide a fully wire compatible MySQL or Postgres interface, and you can like throw in whatever relational database. Like that's an implementation detail. Like right now we only support MySQL and Postgres, but there's nothing specific about those. And you should be able, like we'll give you a connection string, and you should be able to send us like whatever traffic you want, and we'll be able to essentially cache and incrementally maintain the cache results for you, such that you don't have to go through this painful process of like hand optimizing queries, or building your own caching layer, or running read replicas. We're essentially giving you like the benefits of all three of those types of like systems or approaches with very little work. So yeah.
So Alana, I have a question. So it sounds like the actual changes to like the core application code are probably going to be minimal then, right? Because it sounds like you're pretty much writing queries as you would normally write them against MySQL or Postgres. And the result is that the semantics are just like better and easier to scale for the sorts of like consistency requirements that you have. Is that correct, or is that not correct?
Yeah, that's exactly right. The interface that we provide, like to your point, is just directly SQL. You send us whatever you want. We give you fine-grained control over what is actually cached versus not. So if you choose not to cache something, we can proxy it to your upstream, and we try to make it as flexible as possible. So you can use this either as like a read replica type situation where you're routing a certain subset of your traffic to us, or as a proxy where we'll figure out what should be resolved within Readyset versus forwarded to your primary database.
So do you think that this changes? So what do you think this actually changes for application developers? I think that it mostly changes. It seems like it changes life mostly for the backend engineers whose job is to maintain this data store. Is that right, or is that not right?
Well, I think if you're comparing this to the version of the world where you have to like rewrite SQL queries or add your own indices or like, so I think like a lot of the cache maintenance logic is actually happening like in the actual like application, right? So I think it changes things there. It depends on like where you're drawing the lines between like your backend and front end teams.
Cool. Yeah, did you want to? Sorry, you're trying to flag something.
No, it's all good. No, I was going to pass a question to Hojjat because I'm actually kind of curious because like we're very to go down a level, right, of the stack. I'm curious, like, you know, Alana and her team are building like a very like out of the box, very focused dream-based solution to solve like what is a very hairy like problem, right, in application development. And I think, and it's really interesting. I'm kind of curious, like, to go down a level to say, well, what's it take for someone to actually build a streaming system, and how does that impact what's available at the app layer as well? So I'll pass it to you.
Yeah, actually, that's actually a very good segue. I actually wanted to kind of like zoom out, and as Alana's described, that was more like a building one application. So think about a bigger organization. This is usually, there's a nice figure that in Confluent we used to use to explain about why people need Kafka. And this was one of the systems, one of the reasons from LinkedIn. As you know, Kafka came out of LinkedIn. So you have a bunch of applications. And just imagine these applications may need to exchange data or use each other's data. The example that Alana mentioned, you have a database, for instance, that your applications are using and the transactions happening in that Postgres database. And now imagine you want to do analytics on that. You usually don't like to do that analytics on the same database. You rather to move it, for instance, somewhere else, for instance, Snowflake or Redshift or something similar. But what happens when you want to move this data from one system to another system? If you are just doing the point-to-point data transfer, you can come up with a very complex. Each application may have to send that data to different applications, and easily in a bigger organization, it can become very, very complex. So the promise of Kafka or similar services that you see, there are two major promises that I see. One, decoupling producers of the data from the consumers of the data. Case in point, in the example that we just discussed, you have a production database that is handling transactions, and this just generates, imagine you have a log of these transactions, but you want to analyze this data in another analytics database, for instance, as I said, let's say your warehouse in Snowflake. Moving this data from producer to consumer, you can have a system like Kafka sitting there, and your consumers don't have to directly connect to your producers. They just produce the data to Kafka, for instance, and consumers just tap to this Kafka topic and are able to consume that data and do any processing that they want. So this gives a lot of flexibility, because today you're using Snowflake, for instance. Tomorrow you want to also sync this data to S3. Tomorrow, the day after, you want to also send it to Mongo. Some other team wants to use this data. You don't have to do any changes in your producer. All of them just need to tap into that Kafka topic and consume this data. So that separation of producers and consumers, or decoupling that, gives a lot of value. And the second important value is this is low latency or real time. Real time in the marketing sense. I usually have this conversation with people that real time that we are talking fast is not real time. But anyway, let's follow the vocabulary that people are using. So these two, as I said, let's step back. You have a bunch of these applications that they want to share this data, different types of data with each other. If you have a system like this in the middle, and you have streaming, meaning that this is real time, continuously, the minute that you have a transaction, you have that data available for all of the consumers. So it opens the door for a lot of interesting use cases that previously you didn't have them available. First and foremost, now that you have these streams of data, you can do a lot of interesting things like making data available in real time for a lot of systems that, case in point, imagine you have a customer support service or something that previously in old times, by old times, I mean, let's say 8 years ago, 9 years ago, this would be a nightly job that you would get the data. For instance, imagine your user has a problem in checking out. You're going to analyze this data the day after and realize, and by the time that you're analyzing this, it's too late. right now, using streaming data, you can actually do these things in real time and take action in real time. So as I mentioned earlier in my points, the minute that you have such a thing available, based on the context of application, people come up with a lot of interesting use cases. And similar to imagine, for instance, the database itself. The minute that you have database available, people can build a lot of different applications on top of that. So just wanted to say that the way that we look at streaming is that come out of the context of one application. Think about like the holistic way that applications or data is being shared in an organization in real time. And now you can get value from it by actually processing this data in real time. And examples that I mentioned earlier, those are just a few examples that you can see that people build applications to process this data in real time and take action. And usually these applications are operational applications instead of like analytical applications that deals with the historical data. Here you're dealing with the real-time data and you have to take action for the result of that processing that you see.
Great. I mean, that was a very thorough answer, and I appreciate it. You know, one of the questions, and just a follow on to Hojjat, and then I'm going to switch to Jamie. I got a good one lined up. Hoping at least, is, you know, we talk a lot about all of these like amazing use cases that this new, like compute layer, the streaming compute layer, this this ability to compute deltas. Like, what are the challenges people actually have adopting these technologies, and how do we make that simpler, right? Like, what are the challenges? Like, if I have a team that's like, let's go build, you know, a stream-based operational analytics product, right? Where with a SLO that is, you know, within 10 minutes. Maybe I'm doing materialized views. We don't have to get into that, but like, what are the challenges, right? What are the challenges that teams most run into when they try to build one of these systems? What makes streaming so challenging?
The main challenge we have seen so far is complexity. So a lot of tools that you have, as I mentioned, like think about Kafka as the first step. And fortunately now you can get Kafka as service and you don't have to operate it. So that is solved to a very good extent. But the next thing is that what are the tools that you have available to be able to process this data? If you go back a few years ago, the options that you had were a bunch of JVM systems like Kafka Streams, Apache Flink, Spark Streaming. And for these, you literally had to have a lot of experience in distributed systems, streaming concepts, how to set up these clusters, how to operate them. And especially if you have stateful processing, how to make sure that, for instance, if there's a failure, you recover from failure in the right way, guarantee exactly once delivery, and all of those things. So it becomes very, very complex to operate such systems. And only big companies, if you look at, for instance, whoever, I'm using Apache Flink as an example. If you look at the presentations about Apache Flink, usually you see those from Netflix or Ubers of the world, that they have enough engineers, smart engineers, that they can handle these things and operate these things. So I think that was one of the main or biggest obstacles so far we have seen people adopting these technologies. And that's actually one of the missions that we have, to simplify these operations. And that's the reason that we have a serverless service, because we take away all of the complexity of operating clusters, or even having a notion of cluster. You don't even think about cluster, and you just write your compute in SQL and so forth. But going back to your question, the main obstacle has been this complexity and need for people or teams that are able to actually operate these type of services in a correct fashion. And these are 24/7. And unlike traditional databases that it's a store and query, you store your data, you query, you get the results, that query is done. In the streaming world, those are continuous queries, meaning that they are running 24/7 forever until you terminate them. So this operation aspects become very complex and very burdensome. And that has been a big, I would say, obstacle to people to adopt this easily. Now we see Deltastream and similar companies coming out and providing or simplifying or trying to simplify the adoption of these technologies. My hope is that as we move forward and it becomes simpler and simpler, when people have the tools, they can come up with a lot of interesting use cases that fits into their business model, their business logic, and they can easily use these tools to actually transition from more batch-oriented mode to streaming world.
So, Jamie, as Ian said, I think one of the things that we wanted to talk about a little bit was there's this emerging trend, I think, in this conversation, which is there's like a variety of different approaches you can take to building out like reactive like reactive applications or applications that account for data that is newer. And I think one approach is like this idea that, you can sort of shunt streaming and like smarter caching into like a compatibility layer and then hopefully grow out of that. I think that, Jamie, it seems like you're taking a more maximalist attitude towards streaming, where it's like, maybe literally everything should be streaming. Maybe if you have reactive data, like data stores, you can build workflow stuff on top. And I'm curious to hear, like, how do you think this changes like application development? Like, if everything goes right, do you think that it fundamentally changes what it is to build an application, even like a sort of the applications that we would have used Firebase for, and like, what does that world look like?
Yeah, sorry, I needed to find my unmute thing. I think that it changes things potentially pretty dramatically, but like, the reason why I think that is true is that I think in some respects, some of the reactions we have in this ecosystem are actually, if you really trace back the dependency paths, are all reactions to the deficiencies of databases, or actually the interface the databases gave us, right? Because the truth is, under the database, there is a bin log and there is a wall and there is a databases themselves. There's a streaming replication system with ordered operations. So the truth is, the world kind of actually does work this way, but it hasn't been exposed that way to us. And so then we go and we put a queue next to our database, and now we have two problems, right? So one of the biggest opportunities is recognizing that data changing and the propagation of those changes is interesting to other things in your system. It's a responsibility that every piece of infrastructure should own its relationship to that graph of changes. And if you do that, I would say on the operational side, because I think it's a good point about apps. It depends on what we mean by app, right? Actually, one of the biggest benefits of the world is just running fewer services, right? So there's a lot of services that just should not exist, and they're products of the fact that, like, we've had to take these things that were invariants, right? Like, our interface to the database is like get put, right? And then, oh, but what if sometime it isn't? And then, okay, now let's add another system that augments that, right? Or let's tail the bin log and do something. And all of these were us sort of like, gluing things onto the side of the, of the vehicle to try to achieve what we really wanted out of the thing that owned the changes to the data. And so I think that's one of the implications, to get to the implications of changes, is that we're just running fewer things. We don't need to take all of these independent pieces and figure out how to kind of couple them together and achieve the overall semantics we wanted, and then operate all of them. And they all fail differently, and we monitor them all differently, and all the vendors price them differently. So I think that's one big outcome, is changing that. I think on the front end side, or closer to the front, when we mean app in that way, right? There's in many respects, I think the relationship, probably this is kind of agreeing with Alana, that probably the biggest impact of all this is effectively reducing one of those 2 or 3 biggest problems in computer science, at caching, right? So whether it's the applications concept of its local store, or whether it's some intermediate edge layers concept of a cache, at the invalidating data when it changes, especially when the relationship to that data is kind of a polling relationship, like, oh, who knows what changed? Like, the more things take streaming architectures, whether it's out to the edge or whether it's out to the app, the more we can start to architect all of those layers. First of all, some of those layers can just go away because they're kind of automatic. They don't have to, the semantics of them are very straightforward now. So an application developer never has to be involved in them, in my opinion. But even the application, its own reasoning about the freshness of its state within some contexts showing a person, like, just becomes kind of automatically more sound and rigorous, and it removes all of these kinds of like difficult nonlinear problems that application developers used to always have to think about. And a lot of those are about, you could call them variations of like caching problems and invalidation problems. So I think that is probably one of the biggest things that will change the way applications are developed. There was a question about Firebase, and I'm not quite sure how to answer that part of it, but in some respects, Firebase didn't completely fix these problems. So the opportunity still remains to get to this world using one of these technologies.
So I think one thing you said is early on in the answer is pretty interesting, which is a lot of the outgrowth of this space comes from fundamental limitations in databases. And it seems to me we've sort of told ourselves that story in the past, right? Like it used to be the case that like, you know, so I think when you think about something like MemSQL, the core idea was, you know, that we went through this evolution where we in the mid 2000s had like hot spare databases where you'd like query like you do some operational query, and then you know we had to start sharding that out, and so your query language effectively became as expressive as whatever your sharding layer was, right? And then you know you sort of moved all the analytics to stuff like Hadoop, and then computers got more reliable, and now we have data warehouses that account for the fact that you have machines that have like multiple terabytes of RAM. And I guess my question for streaming is, you know, it seems like you think this era is fundamentally different for like this segment of like data infrastructure. And I'm curious to know, like, what exactly do you think has changed that's caused you to be optimistic enough to like spend your actual time working on this stuff?
The customer has changed. So when you know this idea has been had for a long time, we're not the first ones to think of it, right? But I think one of the differences is it used to be companies would have to say, well, let me try to bring something to market, and then developer customers would say, okay, that's cool, I'll use that as long as I don't have to change anything of all the tools I use. And so the acceptance of higher level abstractions by the customer these days is dramatically higher than it was 10 years ago. And so if you show up something kind of new and a little bit more prescriptive, a little more opinionated, as long as it really makes the problem go away for them, I think the appetite has changed a lot for developers to say, okay, I'll give you a shot at this, right? And like, so the set of things that are truly invariant on their side, like, well, I'm still going to use my favorite PHP, like MySQL client library, but you can change anything on the back end. Like there's starting to be API, like ecosystem API culture, all this kind of things, a lot more customer acclamation to the idea that like, okay, let a vendor try to solve this part of the problem space for me, and I'm willing to have some flexibility to. And so I think that the reason it makes it possible is that it's actually very difficult to, I don't know, impossible to solve these problems if you have to do it without any of them, without providing any constraints to them. Like there are going to be some constraints about the way you interoperate with this new abstraction. So that's my answer to that. I think the customer has changed a lot.
Awesome. Ian has a thing to ask. Right, Ian?
Yeah, no, I have a question. I want to take this to like future space. Alana, I'm gonna throw this one at your way as a heads up. I've said before, I think streaming and the caching layer has been very interesting. I'm very interested to like move us towards also talking about how this changes how we can adopt certain types of, like, say, app topologies, right? I'm curious to get your perspective and everyone's perspective, but what does streaming change for our ability to architect our apps in terms of like our ability to build apps at the edge, right? So today we kind of have this cache layer, this drop-in cache layer. Like, does streaming enabled us to move workloads outside the centralized sort of data center, right, to the edge? Does this open us up to like a bold new future of performance and reliability and scale? And then more importantly, if so, yes, and like the better question is when, or not. So yeah, I'd love to hear, Alana, your perspective on that.
So we certainly like to think so at Readyset. This is one of our longer term goals, which is why I assume you asked me this question. But essentially, you're touching on this really interesting topic, which is that a lot of like application development has started to move at the edge. You see like the prevalence of platforms like Vercel, Netlify, Cloudflare Workers, and there's this huge push to no longer worry about where you're actually running this front-end application logic. It's just let them figure it out. That being said, state management in this context is really non-trivial, especially if you already have a couple of years, even decades worth of like historical technical baggage in terms of decisions that you've made as it pertains to like what database you use, how you build things, right? And this kind of actually touches, Jamie, like on your point, it really depends on like who you're talking to, right? Like some new projects, new developers, they're very open-minded about constraints, but I think that the longer you've been around, the less likely that is to be true, not because of like a lack of willingness to change, but more so because of these pragmatic limitations around like how much you can change in a short period of time. And so I'll give you like the very Readyset centric version of this. Like I mentioned, we're the SQL caching layer. We work in front of a single node relational database in a single region, and we're working to essentially build out a service that enables you to run like lightweight, like Readyset nodes at the edge as well. One thing I didn't mention about the specifics of our solution, this is maybe getting too far into the weeds, but we're doing essentially demand-driven materializations. The idea is that we're not going to materialize anything for you until you actually ask for it, because if you try to preempt it too much, you end up having this memory overhead explosion, and nobody wants that. And so essentially, like the mental model for what we're trying to build is something closer to like a CDN for your database, or if you think about, the good old days of normal CDNs, like back when websites were static, which, it's been a while since that's been the case, but back when they were static, this was a really nice solution because you could just pre-render HTML, you could cache these images all over the world. But the second we started to add like queries to the hot path for application like load times, that's when things started to fall over, and you see this Cambrian explosion of other solutions to try to like claw our way back to this like nice ideal. And so that's like ultimately what we're trying to build, where the idea is that you route whatever traffic from whatever region to a node in that region. All of the data for that specific group of users is stored at that node, and then updates from a primary database and from potentially an entirely different region are essentially forwarded to that node based on its like actual contents. You're keeping it fresh over time. And you add a few kind of like, there's things you have to get right in this space to make it play really nicely with like Vercel and like Netlify, HTTP proxying, et cetera. But I think it's like very, very plausible to imagine a solution for this over the course of the next year or two, if not sooner.
No, those are great answers. I think just as a follow on before Hojjat, I have one lined up for you. What do you think is the when we think about architectural changes, like for example, moving from a monolith to like a service oriented, largely to do with organizational scale. I mean, lots of other people, use other reasons, but like that tends to be the primary driver. What's the primary driver for companies looking to move to the edge? Like, what do you think that is? Like, what's causes the inflection point where we go from, we're done with the centralized app, we're now going to do this like distributed edge thing? Alana, I'd love for an answer, and Jamie, I'm sure you probably have a perspective on this too, so I'll give you an answer to respond, and then we'll move on for a final question with Hojjat.
Did you want me to start there?
Yeah, I did. That'd be great.
Yeah, I mean, I think same as Jamie's prior answer, it's like where the users are, where, nowadays, like, you have your SF-based tech company, but it's possible that you have a huge, chunk of users in entirely different regions of the world, and they're not okay with the, latency, like restraints that, that amount of, like network times exist, like speed of light, that's still a practical limitation for all of us. And so you have to push data closer to them, but doing so right now is very challenging. And so there are these like entire, like, companies built around automating that away from developers. Not every team has to be a distributed system, or not every company has to have its own distributed systems team.
Awesome. And Jamie, do you have a perspective? Do you, and also, do you know what like type of buyer? Like, is there a specific type of company that more leans towards like, oh, I'd love to, like, this is going to drive, more money for my business if I'm, 10 seconds will have drop millisecond latency by 50% or something?
Yeah, I would say like the maybe hot take answer first, and then a more constructive one is that, as Kurt said, on Discord like an hour ago, like, more distributed systems problems or whatever, like don't go looking for more distributed systems problems, right? So I actually think the edge showing up as a solution for all application developers is a pretty scary idea, actually. You normally don't want more distributed systems in your life if you can avoid it. But I think the desire to figure out how to leverage it makes a ton of sense. I think some of that's driven by, that's where your users are. But one of the things that's kind of interesting, right, is like 160 milliseconds to your data center is not that long. The problem is a lot of application architectures you've optimized for, very understandably, for like productivity instead of optimization, right? So like a lot of application architectures have lots of like request waterfalls where there's dependent data that has to be fetched over the wire. And so we could say, oh, everybody just be careful, or like, let's get everyone on the same page to write this very careful architecture to make sure to batch up all our stuff, or maybe GraphQL save the day or whatever. But I think pretty understandably, developers, they just want to write things a straightforward way. And so one of the benefits of the edge is, hey, if you turn that 180 milliseconds into 8 milliseconds, you kind of can start to just write things the obvious way. And then, and so it really ends up kind of being a productivity thing. Because to be honest, if you wrote very carefully, And I think a lot of, let's say, internet companies 10 or 15 years ago, this would be more, everybody be very careful, right? You can make 150 milliseconds plenty fast, but I think we're making so much software now, and we just kind of want to we want developers to be able to just write things in a way that feels kind of intuitive instead of being like performance optimized. And the edge is one of the biggest enablers of that, right? Because you can write things in a kind of straightforward way and still have applications which feel very fast.
So
Amazing.
Jamie, I have kind of a tangential follow-up question to this. So how much of this do you think is a programming languages question versus an infrastructure question? So, or like a programming / APIs question. And the reason I ask this is because it seems like there are companies where they're kind of all in on the programming model, like Materialized, right? Where everything is a materialized view. And you expect users to, for better or for worse, write significant chunks of application logic in SQL, right? Like a domain-specific language for retrieving data. And then it seems like, you know, I'm going to editorialize a bit. Maybe Alana can disagree with this, but my sense is that Readyset tends to think of this problem more as an infrastructure problem, where you are expecting engineers to deploy a system like Readyset to give people semantics that are already consistent with APIs they already use. But I think Convex seems somewhat unique in that you both have like an SDK that's exposed directly to application developers, and you are working on the infrastructure problem. And I'm trying to understand, like, how much of this do you think is programming and how much of this do you think is infrastructure?
I think it's both, but I think that I don't think the web developer revolution is going to stop anytime soon, right? So I think that the infrastructure side ideally should be more and more kind of consolidated by the vendors, right? So it's not enough to just provide a better abstraction. You also do need to provide better infrastructure, but actually the right abstraction is one at which you have the infrastructure in mind, where you can enable the kind of performance you're looking for, while still allowing application developers to remain in the layer that they care about, the layer that's closer to the customer, the layer that has anything to do with their product. And everything behind the back end doesn't.
Cool. The end of questions. Go on, Ian.
Awesome. I actually wanted to briefly talk about materialized views, and I wanted to pass this one to you, to Hojjat. I'd love to understand from your perspective. There's a lot of talk in the ecosystem about like materialized views being the solution to the space. It's like declarative, simplifies. Love to get your perspective on the compute layer, what you're seeing. Do you think this actually is a solve? Like, where do materialized views work and where do they not? Do you have an opinion and a perspective on this? And do you think that the materialized views is actually the ultimate answer in streaming, or is it for a specific use case? Would love to get your perspective on that one, because I think it definitely, if we zoom back out from the app for a second, there's just this broad question still in the space.
Sure. I think Materialized View is a very valuable tool in the box that you can use. We believe in that, and we actually do have that as a main feature in our product, that you can easily build a Materialized View based on the stream of data that comes to your application, or in this case, let's say from a Kafka topic. But I would say it's not enough. So case in point, like in Materialized View, you materialize the data, and now you're opening it for querying. But there's a lot of other things that you can do with the streaming, or there's a lot of other applications that you would like to have, that it's not just limited for Materialized View. Case in point, as I mentioned earlier, you have data coming from producers of data, and it's going to be consumed by consumers of data. And again, I'm looking more like an inter-app communication than focusing on one specific app, for instance. In these cases, for instance, you want to prepare data for another application, so some type of streaming ETL. So these are all use cases that when you have streams, you want to be able to perform this type of computation, which doesn't have to do anything with the Materialized View, for instance. So I would say Materialized View itself would be one of the main things that if you want to have low latency streaming applications built using this type of data, is very important tool, but not enough. If you want to kind of like cover much bigger surface, or much larger use cases that you would like to process data and get value from it. So definitely one of the main ones. But as I mentioned, for instance, imagine if you're doing like streaming ETL, you're building a data pipeline to move data around between different services. There, you're not doing anything. You're not materializing anything. Materializing usually is the final state that you keep the data and you provide it for other application, or your application is going to use it. So to answer the question, one of the main features, but not enough for any type of processing that you would like to do with this streaming data.
Awesome. Thank you. I think just one follow-up question actually comes from the audience, and it was a question earlier in the day, earlier in the hour, and we'll be wrapping up soon just for all context, but it comes from Deveris. Why do we have to choose batch versus streaming? If you're streaming first, you can always send that data into a batch destination. Do you have a response or perspective on that?
Is this for me?
Yes, it is, my man. Yep.
There's actually a lot of discussion about this. Like, why not just everything is streaming anyway from the beginning? The batch is kind of like all the streaming. I would say no. There's a lot of processing that you do in a batch world that you don't have them in streaming world. Case in point, the minute that you have data available for you, you can do indexing. You can build a lot of like Materialized view is part of that, but of course, keeping it up to date would include streaming. But a lot of things that you would do in the batch world, you don't do it necessarily in the streaming world, and vice versa. So I would say each of them, a case in point, for instance, the analytics systems that we have, you're storing data in a columnar fashion, for instance. Streaming world, usually you'd get the data, like the whole data as a row, for instance, right? So optimizations that you can do there, in theory, if you abstract everything, yes, computation may seem very similar, but if you step a little bit in more details, there's a lot of different ways of handling these kind of applications or these kind of processing in the batch world that may not be proper for streaming and vice versa. And I think this is, again, the way that I see. It's good to have two different services for these to optimize regarding for each of them, but nothing prevents you from making some abstraction and hide those complexity. For instance, one is row-based, one is, let's say, columnar storage, and the query runs in different fashion, but user cares about results. I would say abstraction would help, but I believe those computation, those optimizations that you have for each of them are very valuable, and we cannot just say, let's just use streaming and not consider about all of the things that we have done in the batch world or analytics world and those kind of things.
Awesome. That was a great answer. Super comprehensive. All right, we're gonna do the last round of shout outs here. Alana, I'm gonna pass it to you. You have, here, pitch your pitch or whatever you'd like to say for the last minute here, and I'll get all of our guests a moment, and then we'll wrap up. And I appreciate all of you for spending this hour with us.
So could you clarify on what you want me to do?
Yeah, like if you have some parting thoughts you want to share with everyone. So that was not a clear
Very
instruction.
confusing, yeah.
Very confusing, yes.
Oh, that's a good question. I don't know. The future is bright. There's so many different interesting angles that we could be taking here, and some aren't even necessarily represented in this panel. So lots to look forward to. We should do another session in like a year or two and see how the world has evolved.
I'd love to compare and contrast. Thanks. Jamie, same goes to you. Closing thoughts. You're muted.
Thanks. I think the fact that, there's so many folks interested in this and building solutions on it, right? And more people are kind of recognizing that, like, hey, there's kind of something happening here. We want more things to operate this way. So I think the good news is there's going to be a lot of really interesting changes and technologies come out of this. I don't think there's one right answer. So it's very cool to learn more about them that other people are working on.
Amazing. And Hojjat, you have final closing thought before we close this out.
I share the same optimism for the field, and I go back to what I mentioned earlier. I think we are in the same place that batch world was in, maybe after the Hadoop came. So there's a lot of interesting thing can be done here if you look at the progress that we have had after Hadoop and HDFS emerged.
Awesome. Thank you, everyone. I appreciate all of our great audience. I appreciate Alex for spending the time with us, and Alana, Jamie, Hojjat. I appreciate all of you for taking the time out of building your startups to talk to people like myself and people in the audience. It's super informative. Recording for this will be posted at some point in the chat by Timothy Chen, and then this may turn into a podcast. We'll figure that out. It doesn't really matter. That's tangential, but this was really fun. I really enjoyed myself. Thank you, everybody.
Thank you very much.
Thanks.
Great to see you all. Bye.